So, antiderivatives are plenty. You know sine and cosine? You know even powers of sine and cosine? You know odd powers of sine and cosine. You've done tangent probably when you did U sub, because it's a typical U sub exercise. But I think we can agree that we could get tangent or show tangent as this by calling it sine over cosine, U subbing it. When you U sub, the du is negative, yeah? And so upon substitution with u, you get negative du over u. You remember? That's negative natural log of the absolute value of u plus c, which is negative natural log of cosine. But the more common form, instead of negative log of cosine, is to take that negative 1, bring it up to the exponent, and call it cosine to the negative first. Does that mean cosine reciprocal or cosine inverse? That means cosine reciprocal, and therefore it is log of secant. All right, are you with me? Okay, try the other one then on your own real quick. By the same thinking, but easier because there's no negative action. How are you doing? Okay. As you go on in your education, you'll need to differentiate between a question like, show this is true, versus find the antiderivative of cotangent. If it just said, hey, find the antiderivative of cotangent, then you probably would be okay condensing a step or two because you're showing, hey, this is where the answer comes from. In your math education, if you get a show, that getting the answer means nothing. They're giving you the answer. That's not getting anything. When it's a show, you're going step by step, methodical. Every step show, nothing left to chance because the answer is known. By getting the answer, you prove nothing. You need to prove step by step that you can get there. Understood? On an AP test, they will once in a while give you the answer in this kind of show format, because they don't want you to be out of parts B, C, and D. In those cases, make sure it's very slow and methodical. All right, log of u, and that's log of sine. Are we good? Okay, so tangent and cotangent to the first are pretty straightforward. If I give this problem on the test, unless I say show y or show the work, then feel free to just recall. It's fine. You cool? Are you cool? Okay, slide. Let's talk powers of tangent and cotangent then. The things you will need to keep in mind, you'll need to keep a couple facts in the back of your mind as you go, because each problem is different. One thing is you might need your Pythagorean identities over the course of this problem. Do you remember your Pythagorean identities? Yes. Okay, good. Those need to be known. They are expected to be at your fingertips for the AP test and throughout this year. Also, the derivative facts, you might need something like the derivative of tangent is secant squared. The derivative of cotangent is the derivative of secant is secant tangent, and the derivative of cosecant is cosecant cotangent. Oops. All right. Now, have all those in the back of your mind as you go to this problem. Tangent squared, integrate tangent squared. What would you do? When we did sine and cosine, we did power reduction. We don't have those for tangents. So, do you have an idea? Trig identities, beautiful, Ben. What does this equal?
Secant squared minus 1.
Wonderful. that is a major step forward because while tangent squared isn't a known derivative, secant squared is a known derivative. What is it the derivative of? Tangent. So tangent minus x plus. So, an identity gets you over. You follow? Right? What about cotangent cubes? Do you have any identities for cubes? No. Not so much. So what should we do first? Break it up. Let's break it up into cotangent and cotangent squared, or vice versa. Okay. Still don't see it. So what else can we do? Now an identity. Okay. So the cotangent squared is equivalent to cosecant squared minus 1. Okay. That's starting to look promising. At least cosecant squared is kind of a known derivative. Maybe we're getting somewhere there. What now? Change to. No, that's that. Don't do that. Factor? It's already factor. Try the opposite. Distribute. Okay. So let's distribute and split. Cotangent, cosecant squared. Do you agree we can split a sum or difference into separate integrals? All right. The first one, actually, you have two choices. Now, what's one thing you could do the first one? U sub with u equal? Cotangent. Cotangent. Okay. Could you let u equal something else? What else could you let u? Cosecant, because du is cosecant cotangent. You could actually do it two different ways. Now most people see the u as cotangent. That's the logical one. So we'll go there. U is cotangent and du is negative cosecant squared. So with changing the negative over and replacing, this becomes negative u du, and eventually negative 1/2 u squared. I'm running out of room, so I'm going to integrate n sub back. Negative 1/2, what was u again? Cotangent squared. All right, we're cool there. And the other one, how do you integrate cotangent, or do we already just know it? Is natural log of absolute value of something. You follow? Alrighty, let's try the last one. Tangent to the fourth of 3x. Do you have any idea? Split it into what? Don't have any fourth degree identities nor third, so you should probably split it all the way down to, oops, tangent squared of 3x and tangent squared of 3x. You follow? Alright. Okay. Now what? Identities. Question is identity both or just one? I'm not sure. Let's do one. Secant squared of 3x plus 1 or minus 1? Minus 1. What do you think? Should we identity the next one? Then we get secant to the fourth, and that doesn't seem good. That seems like a step back. Let's leave the other one, shall we? Okay. And by my confusion here, I would like to say I intentionally did not review my notes before teaching because I want to emphasize that part of the process here is just trial and error. Give this a try, and it doesn't work, go and try something else. That's part of the process. So U sub, okay. So what shall we make U? Okay, are we ready to, now if we do that, if we make U tangent, is that what you said, U tangent? Then wouldn't this be du minus 1? And that seems bad, isn't it? Or is it? Answer is yes, it's bad. Okay, if I let u equal tangent, then this is u squared, that's cool, but then that's du is secant squared. What about, then you're going to have du minus 1 here. You with me? Okay, so let's split it up first and then. So, let's go secant squared 3x tangent squared 3x dx minus another integral of just tangent squared 3x. Are we down? Okay, cool. Now the first one is, I think will go great with u sub now. Don't you agree? So let's execute that. U is tangent of 3x, and therefore du is 3 secant squared of 3x dx, and so we move the 3 over, yeah? Are we agree? Okay? So upon substitution, the secant squared dx becomes d over 3, and tangent squared of 3x becomes u or u squared? U squared. So the antiderivative of that is, yeah, I thought that was the easy part, but maybe not. 1/9 u to the third. You follow? And therefore 1/9 tangent cubed of 3x. All right, first part cool? All righty then. Minus. How do you want to do tangent squared of 3x? That seems like deja vu. Yeah, look above when we did tangent squared with an identity. Secant squared of 3x minus 1. And that then anti-differentiating secant squared of 3x. Be careful with that 3x there. Is it just tangent of 3x? Well, what about the 3x? Tangent of 3x divided by 3. You follow? All right, and the antiderivative of, is that antiderivative of -1 and therefore negative x, or positive and therefore positive x? You've got a -1 there, but there's a negative there, right? So plus x. All right, that's about as gross as you'll see. Lots of power, chain rule in there, and all that good stuff. Are we cool so far? Okay. I would normally throw you to the wolves at this, but it takes a while. This is kind of what I think of as a deserted island problem, where I guess if I was on a deserted island, I had nothing else to do, and I could think about it as long as I want, I could eventually get it. But this takes some major creativity to get this in antiderivative here. So we'll try some stuff together here. We're trying to anti-differentiate secant x, and first and foremost, I think you'll agree that is not a derivative of anything, right? Okay. I think you'll also agree that if you went 1 over cosine, that's great, but it gets you nowhere. There's nowhere to go from there. And from there, what do you do? So that's enough. Are we cool? So now, let's get creative. Let's start bringing stuff in. What can you maybe bring in?
Square root of tangent squared u.
Square root of tangent. Say what? You're just making crap up, okay? What about secant squared is a derivative, right? So could I make it secant squared by multiplying by secant? Can I do that?
No.
I have to keep it balanced in some way. So there's 2 ways to balance. Either do the same to both sides, which I can't do because I don't have both sides. Or I can multiply by secant over itself, yeah? Now that's secant squared over secant, and that makes a lot of sense. I thought I was getting somewhere, but then it all petered out. So that's not it. At least I don't know what to do from it. Do you have any ideas? What?
We do 1 minus
Tangent squared minus 1?
squared minus 1.
Good call, but still then what?
Tangent squared of x minus 1 square root of that.
You could square root it square if you would like. Does that help you?
No. Without specific x. So now think of that tangent squared of u plus 1 is secant squared of u. So you square root that.
Tangent squared of u plus 1. That's a no. Yeah, that's just making stuff. Okay, so what about multiplying both by tangent? That's something. Can I multiply top and bottom by tangent?
Sure.
Okay, so that's a decent idea because that's the derivative of secant. But does this now come u sub e, or is it still no?
No.
Yeah, so that's a no. But you're thinking right in that you're saying multiply by some secants and tangents. That's actually true. You multiply by secant. So secant tangent, you're getting there. You're so close, but that's not it. Okay? This is secant squared, which is cool. That's the derivative of tangent. Tangent over secant tangent, but still, you're there. You're almost there. Try secant of x plus tangent of x over itself. Now, if you do that, what does the numerator become? Secant squared plus secant tangent, which would be the derivative of tangent and secant, yeah? Now, what's the derivative of the denominator? Secant plus tangent still, right? Oh, boom. What's u? U is the denominator, secant plus tangent. What's du? Secant of x, tangent of x plus secant squared, which is in the wrong order, obviously, but it doesn't matter because it's addition, so we can change the order. And it becomes 1 over u du, natural log of absolute value of u, which is natural log of the absolute value of secant plus tangent. That takes some creative thought. Math at its highest levels is actually more of a creative endeavor than an analytical endeavor. All right, so that's the process. Normally I'm not big on memorization, but that's not an intuitive come up with it on your own during the test kind of thing usually. So this is one of the things I do suggest in my class. Okay? All right, so with that in mind, what should we multiply cosecant by to get something good? Cosecant plus cotangent makes sense, and I think you'll, well, we'll see. Hey, let's try.
What about negative?
Yeah, so what about the negative? Let's see if this works, and maybe there is a negative problem in there. We'll see. What does the numerator become? Cosecant squared plus cosecant cotangent over cosecant plus cotangent, right? U is cosecant plus cotangent. Du is negative cotangent squared minus cosecant cotangent, yeah? Yes? Do you agree? You don't? Did I make a mistake? Oh, sure is. Sorry. Yes, thank you. Thank you very much. Okay. Cosecant squared. Not bad. Okay. Is that better? All right. So upon substitution, this becomes negative du over u, right? Because we'd have to take out the negative in our derivative to make it match what we actually have. You follow? Okay, so negative natural log of u plus c, which is negative natural log of cosecant of x plus cotangent of x. Now, I know that's true, but I also know that's not the power. Anybody have a table of integrals? Do you guys have a table of integrals in the back? Can you look at that? I don't think that's the right form. It's equivalent to the form, but it's not the technical.
You multiply
You
it
would-
by negative 1. No, that's the negative 1 power. And so you get natural log of cosecant u minus
I
cotangent.
don't have that page. Oh, there it is. What is it? Say it again.
Oh.
Natural log of cosecant minus cotangent.
This has been here the whole time.
Where's this negative?
Yep.
They have a negative in between, yeah? So they multiply by cosecant minus cotangent. That's right. Okay, sorry. Would you go back and change this to negative? That's totally intuitive, especially if it follows just like what we did. So we did multiply by cosecant minus cotangent or cotangent minus cosecant? Cosecant minus cotangent? Okay, so if we do that, then the derivative is negative cosecant, no, positive cosecant squared minus cosecant cotangent. You with me? Yeah, okay, that's what we have up there. So it's actually normal du over u, no negative. Sorry, I knew that didn't look right. I cannot. What we did is equivalent, but it's not what you probably see multiple choice. So we didn't get this right. So log of cosecant minus cotangent. Are we done? Sorry, I did not remember that. Yeah, this is a pretty small table of integrals. If you look at a college textbook, the table of integrals in the back is usually 5 pages. Just tons and tons of okay. All right. I tell you, 3 of those pages can be eliminated if you know tricks, which you will. So that's the idea. So, question, can you, without looking at your notes, tell me what the 4 basic unpowered anti-drift? Okay, I was really looking for shouting out, but sure. Log of cosecant minus cotangent. So does that go in alphabetical? Nope, it doesn't. That sucks. I would have remembered it alphabetically. So it's not alphabetical. Okay, what about this one? That's addition, so that order wouldn't matter. That's good. Tangent? Log of secant and cotangent. Okay. All right. These 2 you could develop pretty fast, but those you probably want to commit to memory. Okie dokie. You have 2 sets of questions. You have questions on set. What is it? Do you still have 98? 98. Hit me. 13. 6. 3. 13, 6, and 3. All right, and maybe we'll do the 20 as well. I just want you to see 20, although some of you have asked about it. It's some algebra skills we need to do delta epsilon proof. So, 98, 13, here we go. 13 is not replaced, and it looks a little something like this. Set 100 party. Okay. All right, cool. So, yeah, this one's crazy. This guy just loves the circle problems. Almost all his problems are about circles. So this is a circle with radius of 4, cross sections parallel to the y-axis, like that, and the shape is isosceles triangles with height 2 units. So the obvious question is, isosceles, where are the equal sides? I couldn't make this one of the equal sides if the height's going to be 2, because the height couldn't stay constant. So this has to be the different side, and think this height is 2, this height is 2, this height is 2, the height is always 2. So that these are the congruents. Perspective. awesome. But you get the idea. Okay? So it's got this ridge going through the middle, and I know it doesn't look like isosceles, I apologize. Somewhat part of it's perspective, but part of it's not. All right, so the big idea by far for all these is the volume is always the sum of many prisms, okay? So I need to add all these triangle slivers. The area of the base depends on the geometry. The height depends on the slice. In this case, it's parallel to the y-axis, so the thickness is dx. Are we cool? Now there are some hard, fast rules. Semicircles are always pi over 8 diameter squared. Equilateral triangles are root 3 over 4. Sides squared. Squares are always sides squared. But isosceles triangles are a little bit of a mixed bag. They're different each time. You could use 1/2 AB sine C or base height divided by 2. In this case, you want to use base height divided by 2 because they give you the base. The base is always 2. Okay? Or sorry, the height is always 2. They don't give you the base. They give you the height is always 2. Yeah? So the only thing I need is the base. Here's the base. Is the base 16 minus x squared square root? No. It is not. It is 2 of those, right? Because 16 minus x square rooted is just the top half of the circle. So when you do that, you're only doing this much. If you want this much, it's times 2. So the base should be 2 root 16 minus x squared, bless you, times 2 for the height, divided by 2 for the triangle formula. From 0 to 4? No, from negative 4 to 4. Okay? That is calculator. Actually, we don't even need a calculator for that, do we? Let's go here. No, we don't. What is the antiderivative of root 16 minus x squared? Okay, what does this represent?
The top half.
So this is not meant to be done by calculus, it's meant to be done by, oh, that's half of a circle, yeah? So this is like pi r squared with the radius of 4. It is 16. Right? 6. Question on 6. Yay? Oui? Or no? Really? 6. Six on, make sure you do part B. In B, before FTC, use definite integral rules. What does all that mean?
Mr. Richards, yesterday I asked you that, you told me to scratch that.
6 on 98 or 99?
99.
Oh, are we asking about 6 on 98 or 99?
This is replace root 2 using tangent lines.
That's 99. We're talking about 698, right? Okay, so do you have a question on 698?
What was this?
So 99.6, put it next to it. I didn't like it what I did, skip it. I know I replaced it. I don't like that I replaced it, skip it. Now, back to my question. Is 98.6 a question? Yes, okay.
What did you mean when you said before XTC?
In B, before fundamental theorem of calculus 2, use definite integral rules. So that, by that I mean use definite integral rules to switch x to the upper position. You might not have even needed to do that. If you just knew, hey, when it's down there, it's negative, that's fine. Don't worry about it. Just ignore it. Okay? The why it's negative comes from those switching rules. But if you understand that, that's fine. You don't need to show it. You cool?
Mr.
Yes?
I'm curious, why are you including three?
Why am I? Because I'm stupid. I don't know.
Okay.
Yeah, sorry. 3 is 3 still a question. 98.
Yes.
Okay? 3 position at 0 is Never mind, it says just time starts at 0. So time is greater than or equal to 0. The position is 4t minus 1 times t minus 1 squared. And a whole bunch of questions are forthcoming. At rest. Did you have trouble with at rest? Should I go through all the parts or just some of these? There one that was hard? Okay, so A. So let's talk about A. I strongly suggest in terms of technique you do not multiply it out. If you don't multiply it out, you'll have an easier time finding the critical numbers. Instead, just use your product rule skills. So 4t minus 1 times 2 times t minus 1 plus t minus 1 squared times 4. Like I said, if you keep it and use the product rule, you'll have it quasi-factored for you. T minus 1 is common, and this guy would be left with a 2 and a 4t minus 1, so 8t minus 2. This one, t minus 1, one of these was taken, leaving you with a 4t minus 4. You see where I'm coming from? And so when you do that, you get 12t minus 6, and your critical numbers are 1 and 1/2, both of which are legit. Okay, those are both times when b is at a 0 and the particles are left. Cool so far? Okay. Left then, we can, now that we have our critical numbers, we can sign test the derivative of the velocity and see where it's running positive or negative. Based on the fact that this is kind of parabola-ish, it's probably positive, negative, positive. I'm 99% sure. And therefore, it's moving left on 1/2 to 1. I should not include the endpoints because it is not moving at all. At the endpoint, so parentheses, not brackets, right? How many times does it reverse its direction of movement? That's when velocity changes sign. V changes sign how many times? Twice. There's my justification above. And D, find the time when the particle is moving most rapidly. Speed is at a max. Okay, now we're talking. Max speed. That reads like absolute max speed, yeah? And that's probably at an endpoint, which is time equals 0, or a critical number. So, isn't speed equal to the absolute value of t minus 1, 12t minus 6, yes? You agree? All right. So, do I need to set that equal to 0? Or to find a max speed, I need to find speed prime. The derivative of speed and where it is. You with me? Okay, the critical numbers of speed are where speed prime is 0 or undefined. So, if this is speed, this is good practice for tomorrow, absolute value derivatives. There's speed. We could does it have some kind of endpoint? Isn't speed just going to continue getting bigger forever? I don't understand this question. Are you looking at this question?
You can just look at the max.
But is it, does it say a closed interval, or is it just saying forever?
No, it says during the interval.
Oh, during the interval found in B. Okay, so the interval found in B. I guess you could look at this. Are you sure there's symmetry to that?
Yeah.
Why? Because you want it to be because it's quicker?
Yeah.
Because it's a parabola. That's mathematically true. X equals 3/4, or time equals 3/4 is, that's when the max speed. Do they say when is the max speed or what is the max speed? Alrighty. Okie dokie. 20, is 20 still a question? 20? Yay, nay? Oh, gotcha. So this is me laying the foundation for delta epsilon proof. You must have some serious algebra skill to do delta epsilon proof. So you're trying to show that if x minus 2 is less than a tenth, then it must follow that f minus 3 is less than 2/10. Given that f is 2x minus 1. Anytime you prove if-then statement, you start here. Assume x minus 2 is less than a tenth. I am trying to show that through accepted math, I can get to, or it must follow, this has to happen. Most students find it a lot easier if you look at the step right before that. If I could get to 2x minus 1 minus 3 is less than 2/10, then wouldn't I be home free after that, yeah? You see? So the question is, how do I get from x minus 2 to that? Well, think of the x, think of the 1/10. I definitely want this to be double, so I'm going to double both sides. Then you can multiply the 2 in, that is allowed, 2x minus 4, and then split it up, and boom, you're done. 98 is due, 99 you can keep, 99 and 100 will be due Monday. Sure. Yes. Yes.
What? Wait, there's a test tomorrow.
It's gonna be, if I could explain to you, it's my,
Yeah, I know, I was like, I know, this is totally different.
Yeah, good surprise. Have a nice day.